Hi guys, so we're going to talk about the Geometry Common Core exam from August 2016. Hopefully I will be able to guide you through some questions that you're maybe unsure about, or if you recently took this exam that you wanted to see how you did on. So this is my answer key. Use a little blue pen here. Answer key. Don't mind my handwriting, I'm getting used to this pen here. All right, so we're going to go on to page 2, which is our first set of questions. Oops. So the first question should have been relatively easy for you to do. It just had to do with lines and angles. So looking at this picture, my first reaction is to fill in the angles that are missing here. So I know that this is 68. Vertical angles would be 68 there. So vertical angles would make 112 here. Across from that 78, again, vertical angles, which would make what's next to that 180 minus 78, which would be 102. Again, vertical angles. And you just start filling in everything that you know, right? So what is this, 58, I want to say, without getting my calculator out. And 112, and 112, and 68. So I just used the linear pair idea and the vertical angles idea. So now I'm going to finally look at my question, and it says, which statement is true? Can I say that L is parallel to N? Well, looking at L and N, they don't have corresponding angles congruent, alternate interior angles congruent. They don't have any angles congruent, so it can't be that. L and P have all of the same angles, 112, 68. So it's got to be lines L and P because they have all of the congruent angles. Alternate interiors are congruent, alternate exteriors are congruent, corresponding angles are congruent. So it has to be choice 2. All right, moving down to question 2. Which transformation would not always produce an image that would be congruent to the original figure? You should know one fact here. The only type of transformation that changes size is the dilation, okay? So a change in size is a dilation. A translation just moves things left and right. A rotation just turns the image around. And a reflection flips it over a line or an axis. So the only one that does not produce something that's congruent to the original figure would be a dilation. Number 3, if an equilateral triangle is continuously rotated around one of its medians, which three-dimensional object is generated? So first of all, let me just draw you a little equilateral triangle and a little median. A median is the it goes through the, goes through the middle of the side. And so the median here would connect to very straightly, as you can see there in my beautiful drawing. You're welcome. And it's going to spin around that line, okay? If you can kind of imagine taking a triangle and spinning it around like a top or something from, you know, the dollar store, I feel like, you can kind of figure out that it's going to be circular of some sort. So it's not going to be a prism, and you're going to get a circular base, so it's not going to be a pyramid. It has to be the sphere or the cone. Well, because of the pointy top, it has to be the cone. That's the only one that makes sense. It's not going to look like a basketball or a tennis ball. All right, so here we go. Number 4. In the diagram below, the measure of angle BDC equals 100. Reading this was really important. So if you read it too quickly and you labeled the wrong angle, you got it wrong. BDC is 100. That's this little angle right in here, 100. Measure of angle A is 50, which is my age, right? DBC is 30. Okay, fine. Now, if you have learned anything in geometry at all, you know that as soon as you have some picture with numbers in it, you should label everything you know about that diagram right away before you even read the question. So when I see 30 and 100 in that triangle, I know right away that the sum of the angles in a triangle is 180. So angle C there has to be 50. I also know that the angle pair at D is 180, so this should be 80. which automatically gives me, let's see, 50 and 80 is 130. So I've got another 50 degrees up here. Okay, so now I'm ready to answer my question. It asks me which statement is true. Triangle ABD is obtuse. Well, ABD does not have an obtuse angle, so it can't be choice 1. Choice 2 says ABC, so the biggest triangle that you see there, ABC, is isosceles. Isosceles means 2 congruent sides and 2 congruent angles. So when I look at the angle, since that's the only information I have, I'm looking that the whole angle at B is 80, the whole angle at A is 50, and the whole angle at C is 50. As soon as I see double 50s, I know that this has 2 congruent angles, so it has 2 congruent sides, which means it's isosceles. Okay? That definition of isosceles is pretty important to your life. Okay, so I actually saw some kiddos get stuck on this question, and it's actually a pretty easy question. You could also use your graph paper. I'm not going to show you on the graph paper, but if you go to your graph paper and you plot a couple of points and just turn the paper and write down the coordinates, you would get it perfect anyway. And asks which point shown on the graph below is the image of point P after a counterclockwise rotation of 90 degrees. I'm not sure if you've seen a clock before. 12, 9, 3, 6. But clockwise is this direction. Counterclockwise would be this direction. So we're rotating this way, okay? Image of point P after a counterclockwise rotation of 90. You know each quadrant is worth 90 degrees. So P is starting in quadrant 4. It's going to move into quadrant 1 if it moves 90 degrees, okay? What you would want to do is take your paper and turn it. Pick up the paper and actually turn it 90 degrees, okay? If I do that in my brain, I'm going to turn my head like this, and I'm going to look at it. Does it look like it should be at A or B? B would actually be a reflection over the x-axis, and that's not what we want. We want a rotation. So it's actually going to end up at A. Okay, A is the same point. So number 6 is actually a really good question. It has to do with the relationship of complementary angles in a triangle, dealing with the law or with sine and cosine. So you have to know a fun fact that says that the sine of A, sine of A is equal to the cosine of B if A plus B equals 90. This is a fact that you should put into your brain for the course of geometry. This is actually really helpful. So what this question is actually telling us, it says triangle ABC has a right angle. So, all right, that means we've used 90 degrees of our triangle. So 180 minus 90 means we have 90 degrees left. Meaning if this is angle A and this is angle B, that those two are going to add up to 90, right? Meaning we have complementary angles. So the cosine of angle A should be equal to the sine of angle B if their sum is 90. So the sine of 30 is equal to cosine of 60. The sine of 40 is equal to cosine of 50. That's a fun little fact for you, and you can check it on your calculator too. All right, so moving on to number 7. If you didn't have that fun fact, I would keep that in your brain, all right? That's a good one. Number 7, we've got a quadrilateral ABCD, some diagonals AC and BD as shown in the diagram. Excellent. We've got to figure out which is not enough. And I know that this happens a lot in this course. Not. They always ask you which is not true. They're just messing with you, okay? They're evil geniuses and they're messing with you. Don't let them win. Highlight that word. Underline that word. Circle that word. Put a little star next to that word. All right. Parallelogram. Your brain tells you opposite sides parallel, opposite sides congruent. True? Okay. Which of these choices says opposite sides congruent? I'm looking and I see A, B, C, D, B, C, D, A. Okay, that says opposite sides congruent. I know that that's enough to prove it's a parallelogram. Which of these choices says opposite sides parallel? Looking, I see double parallels down here in choice 4. AB is parallel to DC. Got it. BC is parallel to AD. Got it. So there's my definition of parallelogram. I've ruled those out because I'm looking for what's not enough. All right. Is it okay to say that the same pair of sides are congruent and parallel? So congruent sides and parallel. Or is it enough to say that AB is congruent to CD and that BC is parallel to AD, so that the other two are parallel? What we actually want to say is that the same pair of sides is congruent and parallel. We want to say both features about the same pair of sides. So, which is not enough would be choice 3. Okay, so let's go down to number 8. An equilateral triangle has sides of length 20. To the nearest tenth, what is the height? There are a couple of ways you could have done this, so I'm going to do it one way. You could probably do it a second way, and that's fine if you can get it right doing it the other way. So equilateral triangle should mean to you all equal sides and all equal angles. So each of the sides is 20. Wonderful. 20, 20, 20. Excellent. And each of the angles is 60. Well, when I'm looking at that, I would love this to be, I don't know, something different. So when I'm looking at this, this triangle, it's asking me about the height. So I'm going to draw in an altitude. You should know that an altitude is perpendicular, to the opposite side. So I'm going to draw in a little altitude. Altitude has a definition of being perpendicular. So what I've really created here is a mini little right triangle. Look at that. Look what I did. And what you should also know is that if you do a perpendicular line or an altitude here in an equilateral triangle, that it bisects this angle here. Okay? I want to find this height. I'm going to call it X because I'm going to guess that's what you're going to call it. It's the perpendicular bisector. It's the angle bisector. So we also know that this side here was split in half, so we've got 10 and 10. So now we have this beautiful picture. We have a beautiful picture of an equilateral triangle, but then we have a really awesome picture, oops, I highlighted the wrong thing, of a little mini right triangle, a 30, 60, 90 right triangle, which is exciting. So when I look at that and I want to find X, and I know one of the sides and I know the angles, what comes to mind for me is SOHCAHTOA. SOHCAHTOA. If you do some old horse caught another horse taking oats away, that's fine. There's a version about a hippie, but I'm not going to say it out loud. So I always like to draw a little picture of myself at what angle I'm looking from. And this is my angle of 60. I want to know the opposite side, and I know about the adjacent side. So opposite and adjacent makes me circle tan. So tangent of the angle always goes with the trig function. It always goes with sine or cosine or tangent. Of the angle I'm standing at, 60 degrees, is equal to the opposite over the adjacent. Now, your number one most favorite thing ever to do in math is to cross multiply. Put a little 1 under this tan 60, and you're going to cross multiply. 1 times x is x, and 10 times the tangent of 60. When I put that right into my calculator, 10 times the tangent of 60 will give me about 17.3-ish. It's a rounded answer, I believe. So it's going to be choice 3. Okay? All right, so you looked at number 9 and you were like, wow, there's a lot of words there. Yeah, there are a lot of words. But what we want to focus on right away is that we're given some information about these triangles. We're given the two triangles AEC, DEF, and that FE is perpendicular to CE. So FE and CE are perpendicular, meaning they make 90 degrees, right? Perpendicular lines form right angles. So what is a correct sequence of similarity transformations that shows that the two are similar. Okay, first of all, just looking at this, can you tell that this was rotated? It just tipped over, boop. And then clearly this AEC triangle is smaller. And we know that in geometry, when you're talking about a change in size, you're talking about dilation. So I'm going to write down dilation, and I'm going to write down rotation right here. I didn't even look at the question yet. I'm writing down some information. So now I'm looking and I'm saying, okay, rotation, was it 180 degrees? Did it go all the way over, or was it 90 degrees? So looking at this diagram, I can see this angle, they told me was perpendicular. That side, FE, turned 90 degrees to become CE because those are perpendicular. So I'm going to get rid of anything that says 180 degrees because it didn't make all the way a straight line. So it's not 1 or 3. I know it's also a dilation. So I'm looking at here. It says a counterclockwise rotation of 90 degrees followed by a horizontal translation. Did it move left or right? No, it didn't. So it's not a translation. I'm looking for dilation. So a counterclockwise rotation of 90 degrees, about point E, followed by a dilation, there's the word I was looking for, with a scale factor of 2. Yeah, centered at point E. Got it. Nailed it. So it's got to be choice 4. Okay, so number 10, this is a classic geometry question. There's like probably 100 ways to do it, or maybe 2, but I think most of you have seen this question several times. It's a picture you have to get used to. It's the right triangle that's really 3 right triangles, and so on and so forth. You have done this multiple times. In the diagram of the right triangle, CD intersects hypotenuse AB at D. They give you the AD is 4, D to B is 6. Which length of AC makes CD perpendicular to AB? So what you want to do is you want to set up your proportion here. The first thing I'm going to look for is what CD might be. The proportion that you traditionally have set up in the past is the 4 over x is equal to x over 6. So if you do the PAAP, I believe that's how they do it, that's the thing you're using. Okay, so we get to cross multiply. That's our number 1 most favorite thing to do in math, and we get x squared equals 24. And to undo a squared, we square root. So x is equal to the square root of 24. Well, 24 is, or square root of 24 is this altitude. We want to find A to C. We want to find this side here. So I'm going to call that y. Okay? Now, I know that this is a little mini right triangle, and I have 2 sides of that mini right triangle, so I'm going to just use Pythagorean theorem. A squared plus B squared equals C squared. I want to find the hypotenuse, so that's the C squared. I'm going to call it y squared. And then my A and my B are my 4 and my square root of 24. Okay, so if I go to my fancy calculator, let's see if I can do this. Parentheses for, oops, I have a double parenthesis there. I did not mean to do that. I don't think it'll harm anything. Squared plus the square root of 24 squared is equal to 40 equals y squared, and then we would square root again. So right now I'm going to teach you something, but if you are in the middle of the test, you are welcome to go to your calculator and say, okay, square root of 40, oops, square root of 40 is what? And then you are welcome to plug in the choices. So if I do 2 square roots of 6, I can see that 6.32 blah blah is different than 4.89. So it can't be 2 rad 6, okay? But if I did 2 square roots of 10, it will give me 6.32 blah, 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 and then I know they match. So then I'm finding my right answer. What you really need to know how to do, especially if you are moving on to Algebra 2 Trig next year, is you have to know how to simplify these. So square root of 40, the perfect square that divides nicely into 40, that's pretty obvious, is 4. So I'm going to rewrite this as the square root of 4 times 10. I always like to write the perfect square first. Well, what is the square root of 4? Square root of 4 becomes a 2 after I square root it. So I take that 2 outside the square root. I can't simplify the 10 any more than I have, so that's going to stay underneath. The stuff you take out becomes outside in the front, and the stuff you leave underneath stays underneath the radical. So 2 square roots of 10. All right, so I'm going to try this again. I tried to do something fancy in number 11, and then I messed it up, guys. So I'm trying again. Segment CD is the perpendicular bisector. Those words should make you happy. You know a lot of things about perpendicular bisectors, or at least you should. You know perpendicular means forms right angles, and you know that bisector means cuts into 2 equal pieces, okay? So what they're telling you is that you've got this situation. My lines are clearly very straight and beautiful. You're welcome. So if this is AB, it's telling you that CD is the perpendicular bisector of AB. So CD is doing what I would say is the cutting, you know, the actual bisecting, cutting in half. And it's bisecting at E. So that means it's telling you that A to E and E to B are congruent. So it says which pair of the segments does not have to be congruent. So there's that not again. You have to read carefully here. Which does not have to be congruent? Well, since I just marked AE and EB the same, I know it's not going to be choice 3 because it's asking not, so I have to figure out which one is false. Okay, what you had to actually think about here was that what if we drew in AD and BD? AD and BD. We know that CD is perpendicular, so these are 4 right angles, right? And so looking at these 2 triangles that I've formed, which are terrible, they're very ugly, but I apologize. I actually know that D is congruent to itself, so don't I have side angle, side congruence theorem there? So automatically AD and DB are the same. By corresponding parts of congruent triangles are congruent. So what about, so that's actually, this is true. We want one to not be true, so it's not choice 1. Then let's see, AC to BC is going to give us basically the same scenario that I just drew in blue, except on the other side. So CE is congruent to itself, side angle, side congruence theorem, meaning that AC and CB would be congruent, so it's not that one. It must be that DE and CE are congruent. That must not be true. So you're thinking forwards and backwards about your thinking here. If you were to draw this picture slightly different, you could make CE and DE significantly different sizes, okay? So it can be choice 4. Whoops, I lost track of my pen. All right, let's move on to number 12. This picture should look familiar to you. Whenever you have 2 triangles stuck together or a triangle inside another triangle, I recommend that you try to draw them separately as much as you can. So this is a good opportunity to do that. I'm going to actually try to redraw these triangles off to the side. This says that angle H is congruent to RDO. So angle H, oops, I went too far. Angle H and angle RDO. Those 2 angles are the same. And they're not lining up right, so I want to line them up so I can look at all of the pieces together. So I'm going to redraw my triangles. We've got big triangle C, H, R, and H is congruent to the smaller angle. Try to make sure the smaller triangle does look smaller. My drawing with this pen is not the best drawing I've ever done, but the best thing you can do is redraw them so they have the same orientation and so that their pieces line up, because we're going to set up a proportion here. And anytime you do a similarity proportion or similarity proof, you should always be redrawing those triangles so you can easily see the parts that match. So let's do some more reading here. RD is 4. Okay, so R to D, yikes, where's my pen? I lost him. R to D is 4, so I'm going to mark that in this picture too. R to O is 6. R to O is 6. Okay, got it. And then O to H is 4. O to H, that's 4. So that means that HR is 10. Tan. Okay. We want to find the length of CD. I'm going to call that X, you think? Maybe? I don't know. It's your favorite to pick, I know. So I'm literally sending up a proportion here. C to R is X plus 4, because I've got that little extra piece, right? So I like to set up my proportion. I like go big to small or small to big, just be consistent. This time, just because mine are the bigger triangle I drew first, I'm going to do the big one on top. So go down here. X plus 4 matches with 6 and is equal to the same, should be in the same proportion as 10 is to 4, right? Match up the pieces. Now you get to do your favorite thing in the whole world. I think it's the 3rd time we've done it today. 4 times X plus 4 is equal to 6 times 10, or 60. I'm going to guess that most of you automatically distribute. 4x plus 16 is equal to 60, so I just distributed my 4. So 4x is equal to, I subtract the 16 over. Sorry, I don't usually show this step. I get 44, divide by 4, and I get x equals 11. So C to D is 11. Nailed it. I did a great job. Can you hear the fire truck?